All right, example 4, complex numbers. So with complex numbers, what we have is what we call a real plus or minus an imaginary value. So labeled up here, complex numbers come in the form z equals a plus bi, where z is referred to the complex number, and why it's complex is it's complex because it contains both a real value, which is represented by the letter a, and an imaginary value, which I stands for imaginary. B would be the imaginary portion or the imaginary coefficient. And so it's very simple to graph on because it comes in rectangular form where the real is represented by the x-axis is represented by the real value, the imaginary is the y-axis. So what you do is you look at a point. A would be 3 is the real value. Real. 4 represents the imaginary portion. Since they're both positive, this means that 3 is going to move 3 to the right on the x-axis. Here's 3. And then 4 is up on the imaginary, forgot the y, right there. So that point is A. That's where the complex point A would be. Okay, if I wanted to graph B, by the way, 0 plus 2i could be reduced to just be 2i, but once again, we're going to say 0 is the real portion. I'm going to just symbolize that with an R. Imaginary has the I, so I'll just left alone. I don't go left to right, but I go 2 up. This would be point B. Okay, C, this is saying -2 on the real. The imaginary is up 3, so it'd be right here. That's point C. D, once again, you could reduce this to just be -4. So on the real axis, we go left 4. We don't go up or down because we do not have an imaginary portion. This is no longer an imaginary or complex number. You could just say that's just a real number there. E, real portion, left 1. Imaginary portion, down 2. Left 1, down 2. This would be E. And finally, F. This point, we would need to go right 3, that's the real portion, down 1 for the imaginary. Right 3, down 1, that would be point F. So that's complex numbers in a nutshell. That's example 4.